Hi everyone, welcome back to the channel. I am Sespal. Today we are building customer churn predictor for telecom companies using real data and machine algorithm. If you are a data scientist or just look to level up, you are gonna love this. I am starting the 50-day data science where I will build one project every day live front of you. So we are gonna sub data manipulation, then and do some EDA, and after that some pre-processing of data, then building the model and the save and last. So we are simply go anaconda prompt cell. Telecom chart to project customer charge prediction. Goal: predict whether a customer will leave the telecom service. Then when one customer takes service in a company who is present in service in this tool, we are use Python Pandas scikit-learn database that's simply from Keyger. So now we are import sub library. Now we install pip in NumPy. It takes place a little of time. Okay, so we are done and go to imports this library, then import data. We are check head of data telecom customer chart. Here are you can see these are head of data, you can see. Okay, now we are check some information about this data. So we are customer, here column customer ID, non-null count null, object data type is object customer ID 7795 CFO02. Then object int means we are present integer value. So now we are check column, then we are check data is missing or not. If when you missing data, we use some operation, standard deviation, mean, median, all these things. Now we are going to describe the data frame. So no one missing data, we describe. We are check the correlation of the between. We are want to see senior citizen present in table, then you showcase, give you one and showcase. Here import cborn SNS and import Matplotlib PLT or these library used for data visualization in data science. So we import this library. We check the charm can't plot of the charm. Okay, so now we want to map x concept or charm. Well, you can see charm. SNS plot its plot x axis of the contract month to month, 1 year, 2 year. Churn, yes, no. Data frame DF color red. You can change. You can remain default. Then you can see blue. Then now we check its map. So nothing different. So we are correlation with. We want to correlation in heatmap. So we are going to df correlation numerical value. I want to plot this value in form of data. So these are value senior citizen, between senior citizen relation 1 10 years or 10 years. There's a correlation how to coordinate senior citizen 10 year, senior citizen monthly charge 10. So these are relation. Now we are part of the pre-processing. So now from scikit-learn pre-processing import label encoding. So for column I in df select data type include object. Df call label encoded data fit transform df data call. These. Okay, so now run this. Now we are 10 data and split. So we are from scikit-learn model selection import 10 test split. So we are go. So we are drop churn x is 1 and by use churn dataset and x remains churn. X10 x test by 10 by test and xy variable, these are variable, and text size 0.3. we are take 30% of the entire data. So now we continue this model training. Thus now we are fit this data. Random forest classifier model fit x10 by 10. We are going to random forest. We are fit these are value x10 and by 10. We get 10 by 10 value. Evaluation. We are scikit-learn from matrix import accuracy score. We are check how many model perform accuracy. Classification report confusion matrix. We are explain something. Why predict? This is predictor model dot by predict x test. These are predicted data. And this is predicted data. So now we print classification of the classification report. So now we see weighted average 80%, F1 score. Now print confusion matrix. This is true value, false true false true. Accuracy score, that is 79.886, 79 point, precision 79, and F1 score 79. Okay, so same model, import joblib. This is library for the same model, and joblib.dump. so we are model charm. This is model and this is file name. Basically we are see, when you train some data, we accuracy 70-80%. This is normal, but when you go on a quantum machine learning, this is entirely different. We can see 95, 96, 97, 98. This is now save. What I can do after this? I will share this entire code. So a complete data science project we are going into. So we are going EDA, that data manipulation, EDA, pre-processing, building and build and the model, then save, evaluation, pre-processing. I'm do entire thing. So now we are